So starting a new chapter. Okay, mensuration, vast, biggest chapter actually. Biggest chapter carries the most marks. Right now, I want you all not to focus on the marks, but rather on understanding the concepts first. Of course, I'm going to teach this from your exam point of view. I'm not going to do all the question because there are so much. But we will come to the board exam part later on. First of all, you try to understand the concept. In between the questions, I'll tell you all which ones are the frequently asked questions, which ones are not, which is important, which is not. Okay, first of all, we are starting the mensuration chapter, chapter number 12, with the concept of circle. So let's say you have a circle right here. So this is a circle. There must be a center right here somewhere, and this line is the radius. Let's draw the radius with a blue color. Okay, so we have a circle, and this is called the radius. The distance from center up to this line right here. What is this called? This surrounding? This whole line, the length of this whole line. There is a red line right here, right? The whole line. This is called as what? Circumference. We have been doing this for how long? Class 6, I believe, 5, 6, I believe. So here you have got the circumference, and here you got the radius. And when we move forward with the chapter, when we continue with the chapter itself, you are going to learn what are sectors, what are segments, how to find out the area of sectors and segments, and so on. But for now, the most basic one, the perimeter. Perimeter is the length of the circumference, right? How long is this red line? How long is this? That's called the perimeter, or we will call it by another name, by the circumference. And of course, this occupies area. The circle occupies a certain area right here. So how to find out the perimeter and the area? You already know that the perimeter is given by the formula twice pi r, right? Area is given by the formula pi r square. So with just these two basic concepts, we will continue one exercise. We will do one exercise 12.1. This is just a refresh of your memories from the earlier classes. Okay. I'm not doing all the questions. I'm picking up from 12.1 since we have just started with the basic concept of circle. We'll do question number 4, question number 8, and the question number 10. The others, they are not, this whole exercise 12.1, they are not very important from the exam point of view. Okay. Rarely a 1 mark question, a multiple choice question, or a 1 mark question may come from. So I'm just picking up questions which are different, which you might not be familiar with in class 8, 9. I'm just picking them up. So what the question number 4 is saying, area of circle is 1386, find its circumference. So area is given, and you have to find out the circumference. Perimeter means circumference, right? Perimeter or circumference. So if we proceed, we will have something like this. Area of circle is equal to 1386 centimeters square. Now, instead of writing the area, we will replace by its formula itself, which will be pi r square. And pi r square is 1386. We want the circumference, right? Circumference is twice pi r. We know 2, we know pi. These are constant values, which we know the value of pi. We know that is 22/7, but we don't know the radius, right? We can find out the radius from this equation. You take the pi to the other side. Now what we are going to have is r square is equal to 1386 by pi, which will be, pi was 22/7, right? 7 goes above, 22 is still down. And now you can cancel them. 2 11s are 22, 2 6 are 12, 2 9s are 18, and 2 3s are 6. And you can cut 11 6 are 66, 11 3s are, and then 7 9s are 63. Now, yes, you can see r square is 9. And if I want to find out the radius, we will have 9 square. 9 is the square root of 9 is the square of 3, so we will have 3. If the radius is 3, circumference is easy, right? Circumference is twice pi r, so we will just put in the value.
Sir.
Oh, yes.
How did you cut 7 and 63?
Oh, sorry. I made a mistake. I thought that this was down. So the value was very small also. Okay, so this is 63 into 7. I can break it down like this. 9 into 7 into 7, right? 63 is 9 into 7. 9 7 is 63. 9 is 3 square, 7 square right here. 7 into 7, I can make it into 7 square. 9, I can make it into 3 square. So this whole thing, if you check it, it will be 21 square actually. So you cut the squares, so implies that r is equal to 21. Now you put in the value, 7 3s are 21. So finally you will get, I think the value is 132 centimeter. Can you copy this? Simple, right? This is not even your class 10 level. I think you are able to understand this already in class 6. And one thing you should notice, the area, the unit of area will always have a square in there. Why? Because we have a r square in here. R square will be r into r. If one of them is in centimeter, another is in centimeter, centimeter into centimeter, it will produce centimeter square. If the radius was in meter, then the area will be in meter square. So always remember, you have to keep in mind, you have to be careful that when you write the value of area, you always have to include a square in there in the unit. So centimeter square, meter square, decimeter square, according to what the question is given. And just note that circumference is a length, right? When we have this whole circle, if you cut this and then you stretch it into a line, you cut the circle. Let's say you take your bangle, ladies, girls. If you take out your bangle, one of your bangle, if you cut it and then stretch it into a straight line, you will get a certain length, right? That certain length is a circumference of your bangle actually. So since circumference, it represents the length, that's why the unit is centimeter, no squares in there. If you don't understand how I come into this 21 square, it's like this. R square is equal to 63 into 7. 63, you break it down like this. 3 into 3 into 7. 3 3s are 9, 9 7s are 63, right? And then there is a 7 in there originally. So 3 into 3 will be 3 square. 7 into 7 will be 7 square. The numbers with the squares in them, you can multiply them. So we will have 21 square. That's how I'm able to get this 21 square, and you cut off the squares. Finished?
No, sir. No, sir. Sir, finish.
Now rubbing it off. I don't think it needs much explanation, right? This is just basic question. Okay, the second one, the question number 8 that I'm taking up here, it's slightly different. It involves a small equation. Look what the question says. Difference between perimeter and radius. Difference means we are subtracting, right? Subtracting what and what? Perimeter and radius. If we subtract perimeter and radius, what's the value? It's 37 centimeter. You're supposed to find the area of it, right? Area of the circle. So what this part is saying, what this part is saying, the first sentence part, what this is saying, it's just that you have to subtract perimeter and radius. So you can say here perimeter is pi twice pi r. You subtract and the radius. The difference between perimeter and radius, this is how much? 37. You can take out the r common factor from here. You have 2 pi minus 1, which is equal to 37.
Sir, we cannot
What
hear
you
you.
have to know one thing here is, you hear.
Sir, we cannot hear you properly. Sir, even your screen is frozen. We cannot hear you, sir. So I think it's your internet.
Must be. No, you hear? Can you all hear? Yes or no?
No, sir, we cannot hear you.
Is the screen still frozen, students?
Yes, sir. Good now.
Okay, I have to reset the pencil. All right. Can you see the highlight?
Yes, sir.
Okay. So, difference between the perimeter and radius. So we have the perimeter here and radius here. Whatever question that you face for circle, the only parameter, okay, we call them parameter. The only variable, it's not a variable actually, the only parameter that you need to understand, you need to have the value of, is the radius. Once you have the value of radius, you can calculate everything, right? But little different for sectors and the segments, which you are going to learn later on. But as the question says, difference between perimeter and radius is how much? 37 centimeter. Find the area. Area is pi r square. We don't know the r, right? So from this equation itself, we are going to find out the radius, and we will find out the radius. So let's see. By putting on the value of pi, we will have 22 by 7 here, minus 1, which will be 37. R, we will have 44 by 7 minus 1 is equal to 37. And you can combine these two, 44 by 7 and 1, you can subtract them. So we will have 7 here denominator, 44 minus 7. Okay, now R, look at the numerator, it will be 37. Denominator is 7 and 37 is on the right hand side. No change in the right hand side. If I want the radius, this portion has to go to the other side, right? So 37, 7 goes above, 37 comes down. You cancel them and you get radius as 7. So for this particular circle, when the difference between perimeter and radius is 37, the radius is how much? It is 7. Time for you to find out the area then. Area is how much? Pi r square. So 22 by 7 into 7 into 7. We cancel one of the 7s and then we will get how much? 154 centimeter square. It mentions centimeter here, so we are putting the area as centimeter square. Remember, I just told you all to put the area, the unit as how much? Area is what? Unit of area, you should put it as square of the given unit. Right, then this question is done. We have to find out the area from this given equation. No, sorry. We have to find out the radius from this given equation right here. And then we'll find out the area using the pi r square. Okay, copy. The whole exercise 12.1, there is around 14 questions in there. Most of the questions we have already done in class 8 actually. And I think I had time to taught you all also mensuration chapter, if you remember. As per your latest syllabus, your exercise 12.3, we will have to mist it out. Are you all done? Yes or no?
Not yet, sir.
So 12.3, we are not going to do that anymore. And then one of the most important exercise, which has been asked very frequented one, there is a portion called frustum of a right circular cone.
Sorry, Venice.
So last exercise and 12.3, there is not much use anymore. So 12.6 and 12.3, we have to skip them because it is not given in the latest syllabus. And moving on to question number 10, slightly different one. And what you have to understand by the word is concentric circle. There is a word mentioned here. Concentric circle is circle which have the same radius. If you draw like this, they have the same radius. No, sorry. They have the same center but different value of radius, right? So if this is rough, so if two circles have the same center but different value of radius, so if they have different value of radius, then these two circles, they are called as concentric circles. The question says, let's save it away. The question says in 10, if the areas of two concentric circles are 154 and 616, there is a bigger one and there is a smaller one. So bigger one, the area is 616 centimeter square, and smaller one, there is an area of 154 centimeter square. So this part right here, let me just, this green part right here, this is 154. And then if I draw with the red, this whole red part, this is the 616. What is the question one then? Find the width and area of the circular part between them. So there is a circular part in between, right? There is a circular path in between. I draw it with the blue. This circular path. Question one is to know what is the width of the circular path? What is the width of this circular path? How much is this? And then another one, the question one is to find out the area. What is the area of this shaded portion, shaded with the blue? This part is very easy, area of the circular path. Because the whole value is 616, this green part is 154. So out of the 616, if I cut off 154, the remaining part must form the path, right? So area of the circular path, that would be an easy thing because we just have to subtract this 616 value and 154 centimeters square. That way we are going to get the area of the circular path. But the question also find the width. What is the width of this? Very easy. What is the radius? This radius we can find out because the area is given for the bigger circle. And for the smaller circle, this much is the radius. If I subtract the radius of the two, the radius of the big circle is this one, the radius of the small circle is this one. If I subtract the two, then whatever remaining must be the width of the circular path, right? So we will find out the radius of the bigger circle and radius of the smaller circle using pi r square formula. Okay, so when we start the solution, we mention here let the bigger one let the radius be r2, the smaller one let the radius be r1. R1 and R2 be the radii of the circles. So as given, you can see pi R1 square. This is the, if I take R1 here, I'm mentioning I have to put the value of the area of small circle. So a small circle right here, pi R1 square is how much? 154. You can find out the radius straight from this. Pi is 22 by 7. R1 square, let it be 154. Find out R1 square. 154 into 7 by 22. 7 comes up, 22 goes down, right? And you cancel them. 11 twos are 22. 11 ones are 11. 11 fours are 44. And 2 sevens are. And 7 7 is 7 square, right? You can cancel the squares. So how much will be the value of R1? R1 is equal to 7. Simple, right? Just you put the area as formula. Area is formula, and then you put the value of area and you find out the radius by putting pi as 22 by 7. Now come to the other circle. Pi r2 square must be how much? 616 as given by the question. So use the same thing, do the same thing here. R2 square is equal to 616 into 7 by 22. I'm skipping one of the steps, this one. I'm going 7 and 22. I'm taking it straight to the other one. So you cancel them. You cancel the 11 twos are 22. And, uh, 11 fives are 55. 11 six are 66. And you cancel again. 228. So what value do we get then? We will get R2 square is equal to 28 into 7. 28 I can break it down into 4 into 7 into 7. This 7 is here. The 28 is broken down into 4 and 7. 4 is 2 square, right? 7 square here. 7 into 7, we will put it as 7 square. And final value will be 14 square. So R2 square is this much. We make it into square and then we will cancel the square next. So R2 is equal to 14. Look, the radius of the smaller one, we found out this to be 7. The radius of the bigger one, we found out this to be 14. Okay, you have to mention here along with the unit centimeter, centimeter. If this is 14 and if this is 7, the difference is how much? The difference is 7 centimeter. So the width of the circular path, it will be how much? 7 centimeter. So you say here, therefore the width of the circular path is how much? We have to subtract the two radius. We will have 14 minus 7. So it will be 7 centimeters. And you can find out the area of the circular path. I will leave it there to you. Just after this, you just say area of the circular path. You just have to subtract 616 and 154. You do it yourself, okay? Okay, you copy up to here. And remember to draw the circle also since it mentioned concentric circles.
So I finish.
Okay. Now I'm not picking up any of the remaining questions from your exercise 12.1. Not important, and also most of the questions you have already done it in class 9 and class 8. So not much benefit to poke in there anymore. We can finish with those three questions. Now comes a little newer, slightly newer concept. I believe you have already done an introduction of these sectors in class 9. Now, what is a sector area? What is a sector? And there is another one. There is a sector and there is a sector. First of all, what you need to understand is circumference, arc, sector, chord, diameter, and radius, sector, and lastly segment. So, what are these in a circle? You need to understand it properly first. Circumference is this entire thing, right? This is the circumference. What is the area? The area is how much area is occupied by the circle. That's the area of a circle. What is a chord then? If I connect any 2 points in the circle, you take two different points on the circle, and if I draw a line, this line is called a chord. If I draw it passing through the center, you take 2 points and you join them. If that line is passing through the center, that is called a diameter. And what is the radius? Radius is the point connecting the center to the circumference. What is a sector then? You take two radius. You take two radius. You take two radius. You draw two radius in a circle. And this portion right here. This portion right here. This is called a sector. This is called a sector. What is arc? Arc is part of the circumference. If you take the whole circumference, and out of them, if you took any small portion of it, then it is called an arc. Now, if I draw like this, you are able to see four things right here. There are two radius. There is a chord. Chord is a line that will join 2 points in a circle. You take any 2 points in a circle, you join them, that line is called chord. So here is a chord right here, and here is an arc. This part, this piece of the circle, this is called as arc. And then diameter, you know, radius, you know. Sector is this whole part. The part that is enclosed by two radius, that is called the sector. The one that I'm shading in blue, this part is the sector. What about the segment? Segment is this part right here. This part right here, this is called a segment. Okay, of course, we are going to come to the segment later on, but you just focus what is the sector. So if you draw two radius in a circle, two different radius in a circle, the area enclosed in between that will be called as sector. So the sector can be divided into two types. One is the minor sector, the other is the major sector. Before we try to understand what is a minor sector and major sector, you know that this is 90 degree. How much is the angle? This is 90 degree. If there are two 90 degrees, then it will be 180, right? So in order to make 290 degrees, you have to draw another on this side. So this whole angle right here is 180. If we have 280s, that will be a 360 degree. This is 180 degree. There is another 180 degree. 180 degree down below, 180 above. 180 and 180, the total is 360 degrees. Okay, you consider this blue line, and on this I rotated the red line. This is the angle theta. The red line was here before. I rotate this in the anti-clockwise direction and it reaches the blue line again. Now this whole angle, how much is it? There are 180 degree two times. So if you have a line right here and if you take this whole angle, then this angle will be how much? 360 degree. What is the half of 360 degree? 180, right? So half of 360 is 180. Keep that in mind. Now, if I have a radius here, and if the radius is rotated for a whole revolution, then that angle will be 360, right? When we have a sector, you need to be mindful about three things. One is how long is the arc, how long is the radius, and another is how much is this angle right here. All right, three things: radius, arc, and this angle right here. This angle. Let me draw it in blue. This angle right here. Let's name it as theta. This theta is called as sectorial angle. Okay. If this angle theta is less than 180 degree, then that type of sector we will call it as minor sector. Good. Okay. Good morning, students. Because of the network problem, we did not finish this sectors and the segments portion in the previous class. So I have explained a little about what is a sector and what is a sector. I have explained it a little bit. What is the area and what is the perimeter? I will continue explaining after I explain to you what a sector is. As I've told you before, when you take a circle, if you take a circle and then you draw two radius, the area occupied in between that is called as a sector. So in a sector, you need to keep two things in mind. One is the radius, because bigger the radius, bigger will the sector be. And another thing is this angle right here. How much is the separation between the two radius? Let's say this is OA, this is OB. How much is the separation between O and OB? This angle is called as sectorial angle. So sectorial angle and radius you have to understand in order to come to what is the area, what is the perimeter of a sector. So while doing the sector, let me mention something also. This part right here is called as the arc, right? If you take any part of the circumference itself, this is called the arc. So when you take away a sector, there is a certain part right here which is called the arc of the sector. How long is the arc also? That will depend on the sectorial angle. You have to understand that. So in a sector, you need to keep in mind what is the radius and what is the sectorial angle. And I've also mentioned what is a minor sector and what is a major sector. If the sectorial angle theta is equal to is greater is if the sectorial angle is less than 180 degrees, then the sector we will call it as minor sector. There is a part right here, right? This angle theta is obviously, we don't know the value, but we can see that this is less than 180 degree. This is less than 180 degree. So let's say this angle is 120 degree. The remaining portion will be how much? 360 degree minus 120 degree, right? So it will be 240 degree. In total, they will make up 360. So if one of the angle is 120, the remaining angle is 240. So we have got two sectors here, the upper portion and the lower portion. Let me show you by shading them a little. The part that I'm shading here with green, in here the sectorial angle is less than 180 degree. The upper portion right here, the one that I'm shading in red, this upper portion right here, a minute. This upper portion right here, this has a sectorial angle which is greater than 180 degree. So this portion right here, this angle is greater than 180 degree. So this green part is the minor sector because the angle, sectorial angle is less than 180. And the remaining part that is called as the major sector. Right. I think we are clear on what minor sector and major sector is. Now let's come to what is the area and the perimeter of a sector. Okay, consider the area first. I'm rubbing this off also. How much is this whole angle? If the angles come from here to here, one rotation or one revolution, that is how much? 360 degrees. How much is the total area? Total area is pi r square, right? We have already learned that. The area of a circle is pi r square. And if we consider the total angle is how much? 360 degrees. So for 360 degree angle, the total area is pi r square. If I divide this whole circle into small sectors. Let me remove this. Let me divide into small sector like this. Many small sectors. If the angle is 1 degree, how many sectors will there be? There will be 360 sectors, right? If I make small sector, And the angle here, this angle right here, if I made this angle to be 1 degree, then how many sectors will there be? There will be 360 sectors, right? 1 degree here, 1 degree here, 1 degree here, 1 degree here, 1 degree here. If you continue drawing until you get 360 degrees, there will be how many sectors? 360 sectors. Okay, wait a minute. It's little loud. So for all that 360 sector, the total area is pi r square. For the 360 sectors, the total area is pi r square. And if I want only one sector, how much will be the area? We use unitary method. Consider, let's say the cost of 30 pen is rupees 1000. The cost of 30 pen is rupees 1200. What is the cost of one pen? You have to divide 1230, right? So for 360 sector, the area is pi r square. For one sector, the area will be how much? On the pi r square, you have to divide it by 360. This is for this is the area of one sector where the sectorial angle is 1 degree. If there are 2 degrees, then how many sector will there be? There will be two sector, two small sectors having 1 degree each. So we will for 1 degree here. If 1 degree forms one sector, then the area is pi r square by 360. If I take 2 degree, then we will have two sectors, small sector, then we will multiply it by 2 pi r square by 360. If we have 30 degree, then we will have 30 sectors, and that will be pi r square by 360. It will be multiplied by how much? 30 degree. So for a certain sector having angle theta, if the angle is theta, then we have to multiply here. For 1 degree sector, the area is this much. For a sector having angle theta, the area will be pi r square by 360. It will be multiplied by theta. All right then. When we consider the sector, its area will be how much? Pi r square by 360. This is for 1 degree sector. If the sectorial angle is 30 theta, then you have to multiply here with theta. So the area of the sector is given by pi r square by 360. It will be multiplied by theta. You need to remember this. What is the area of a sector? One more thing. What is the whole length of this? What is the whole length of this? The circumference, the whole length is, the circumference is twice pi r, right? So similarly, twice pi r is for 360 degree. For 1 degree, how much will it be? Twice pi r divided by 360, right? If you cancel 2 and 360, we will have 180 as denominator. Now we will have pi r by 180. So for 1 degree, the area, the length, I take only one part. If this angle right here is 1 degree, then the length of this will be how much? Twice pi r, it will be divided by 360. 2 and 360 got cancelled, and we will have pi r by 180. This whole length is twice pi r. If I want only this part right here, the highlighted portion right here, then if this is 1 degree, we will have pi r by 180. If this is not 1 degree, if this is a certain angle theta, then this part right here, the length of this part right here, it will be how much? Pi r by 180. It will be multiplied with angle theta. Right. So for a sector, the area is how much? Pi r square by 360 multiplied by theta. And length of arc. You have to understand which part is the arc part. This part right here is the arc part. How long is this part right here? So the length of the arc, this part is twice pi r divided by 360. It will be multiplied with theta. This is the whole area. This is the whole circumference. 2 and 360 you cancel out, you get 180 degree. So we will have pi r by 180 degree to theta. So you have to note this down. Area is pi r square by 360 into theta for a sector. So in a particular sector, the length of the arc, it will be how much? Pi r by 180 into theta. Okay, you note down these two formulas. Now come to the perimeter of a sector. Okay, perimeter of a sector. So let me rub it off. This one. This one is the center, and we have a sector right here. The length of this part right here, this is the perimeter of a sector here. This part right here, this is the perimeter of a sector. So this part right here, what does it consist of? Let me draw it with the green. The length of this part here is the perimeter of the sector. It consists of two radius, one r here, one r here, and this part is the arc. So if I add the arc, the two radius, then we are going to get the perimeter of a sector, right? And for a sector, you have to have an angle theta here, which is called the sectorial angle. So the perimeter of a sector, it consists of three parts. We will have radius plus arc. What is the formula for what is the radius is represented by r, right? The next radius is also represented by r. The radius is here, the other radius is r. What about the arc? The arc part, we have just calculated there. The formula was what? Pi r by 180 degree into theta. We can add this r and r, so the total value will be how much? Twice r plus pi r by 180 degree into theta. So this formula right here, it will form the perimeter of a sector. Not frequently used, but there will be one or two questions in your exercise which is related to perimeter of a sector. So note this one also. 1 minute. Take only 1 minute, okay? Whoever is turning on the microphone, turn it off. Right. Okay, moving on. If you haven't finished, just say you haven't finished. Okay. So question number 1, 12.2. I'm taking up questions related to sector first. There is another topic called segment. Another part of a circle called segment. We will come to that later on. Look, 12.2 question number 1. The question says the perimeter of a certain sector of a circle of radius 6.5 is 21. Find the area of the sector. Simple here, the perimeter of a certain sector of a circle of radius 6.5 centimeter is 21. So what is given here? Let's write it down first. The perimeter of a certain sector is given. Perimeter of a sector, how much is it? 21 centimeter. What else is given? The radius is also given. It says the radius is 6.5. So radius is equal to 6.5. Question wants what? Question wants area of the sector. And as you have just seen, the area of the sector consists of pi r square by 360. In here, you have to multiply by the sectorial angle. Pi and 360 are constant. The value of r is already given here as 6.5. But what we don't know is we don't know the sectorial angle. We don't know theta. All right. So in order to find out theta, what we are going to use is we are going to use the formula of perimeter of a sector. We will make an equation from this and we will find out the value of angle theta. So what was the formula for perimeter of a sector? Perimeter of a sector was twice r plus pi r by 180 into theta. This was 21. Time to put in the value of r. We don't know this theta, we have to find this out. So twice r will be how much? 2 into 6.5, pi into 6.5, 180 into theta, 21. 2 into 6.5 is 13, pi into 6.5 by 180, let's keep it, into theta is equal to 21. Let's take this away, 13 to the other side. It will be minus, right? This was positive, So 21 minus 13, it will be how much? 8. I'm skipping one step and then I'm putting straight to 8. Pi into 6.5 divided by 180 into theta is equal to 8. 21 and 13 are subtracted. Okay, you continue further. I want the theta. In order to find out the theta, pi 6.5, 180, everything has to go to the other side, right? So 180 will come up, pi and 6.5, it will come down. So theta will be how much? 8 into 180 divided by pi into 6.5. All right, then let's keep it right here. We are not going to cancel this because 6.5 is 13 by 2. It will only complicate it. So let's keep it here. I don't know whether I have copied the question correctly. Yes, correct. Once we have got theta, the question one is to find the area of the sector. Find the area of the sector. So say here, area of sector is what? We have got the theta. Even if we are not multiply, we have got area. We can find out area of sector. What's the formula? Pi r square by 360 into theta. You put in the value pi into r square. We can put it as 6.5 into 6.5. 360, let it be. The value of theta, this theta, we are going to replace with this one right here. So we will have 8 into 8, 180 divided by pi into 6.5. Very simple here, pi is here. The r square, we replace it as 6.5, 6.5. 360 is still there, but the theta value, we replace it by 8 into 180 by pi into 6.5 as we have obtained here. Time to do some cancellation. Why we did not multiply earlier was all this value, they can be cancelled out. How? Look, 180 and 360. There is 2. 180, 2 is 360, right? 6.5 and 6.5, pi and pi. 2 and 8. Okay, look, what has been cancelled? 180 and 360 have got cancelled. There is 2 remaining. This 2 and this 8 have got cancelled. There is 4 remaining. This pi and this pi have got cancelled. This 6.5 and this 6.5 have got cancelled. What are remaining? No denominator, right? Denominator, all of them are gone. But numerator, what we are left with is, we are left with 6.5 into 4. We can multiply 4 5s are 20. 4 6 are 24. So we will have 26. There is one decimal point, so we put one decimal. And the unit will be what? Centimeter square, because we are finding out area. So the strategy is simple. The perimeter of a sector, we make it into this equation right here. And I think you all know how we have obtained this. 2r plus pi r by 180 into theta. It's this formula right here. And then we put the value as 21. We can put in the value of r. We find out theta. Once we have found out the theta, we found out the area of sector. Okay, then moving on to the next question. This is easier compared to the previous one because the previous one involved equations and everything else. So it says the area of a sector of a circle of radius 21 centimeter is 462 centimeter square. When the question is given like this, you have to understand which one is the area, which one is the radius. Of radius 21 centimeter, this part gives the radius. Okay, it says the area of a sector. This one is what? 462. So what is given first? Let's write it down first. What the question wants, let's discuss it later on. It says the area of sector. It is how much? Okay, we will write this one later on. How much is the radius? Radius is 21 centimeter. What about the area? Area is 462. Now what does the question want? The question wants the length of the arc of the sector. So we have got a sector right here. I'm just drawing the sector part. We have got the radius here and this is the arc. And we know the length of the arc is given by what? Twice pi r divided by 360, and we will multiply it by the angle theta. 2 and 360 got cancelled. We have got 180 here. So the length of arc is the formula, the length of arc. As I have just given you all, it will be pi r by 180. It will be multiplied by theta angle. What do we have? You have to check first. Pi and 180, they are constant. Their values are not going to change, whatever the calculation is. And the radius is given right here. The radius is given as 21 centimeter. And how much is the area given as? The area is given as 462. What is missing? Pi 180r. We all know them, but we don't know this angle theta. The sectorial angle, how much is it? We don't know that. Once you are able to find out how much is the sectorial angle, then the length of the arc is going to be easy. So for that, from here, we are going to calculate the angle theta, the sectorial angle theta. So area, what's the formula? We will write it as pi r square by 360 into theta is equal to 462. We want the theta. That means pi r square 360, 1, 2, 3, all of them, we have to take it to the right hand side. The denominators will come up, the numerators will come down. So we are going to have 462 multiplied by 360 divided by pi r square. Time to put in the value now. 462 into 360 pi. Let's keep it. Okay, we are going to cancel it out when we find out the other one. And how much is the value of r square? The r square is 21 into 21. As the radius is given as 21, we are putting 21 and 21. Let's do some cancellation. 3 sevens are 21, 3 ones are 3, 3 fives are 15, 3 fours are 12. 7 and 154, we can cancel them also. We have got 22 here, 7 twos are 14, 7 twos are 14, right? And we can cancel out 21 and 360 here, 21 and 360 here, we can cancel them out. 3 sevens are 21, 3 ones are 3, 3 twos are. So the final value we are able to obtain is 22 into 120 divided by pi into 7. You can keep like this unless the question asks you specifically how much is the angle theta. You don't need to multiply them. All right. You can multiply. I can multiply like this. Look, 22 into 120 divided by pi. It's 22 by 7, right? Into 7. This 7 and this 7 will get cancelled because one is numerator, one is denominator. And this 22 and this 22 can cancel out. So what is remaining? This is equal to 120 degrees. So when we are given a sector like this was 120 degree. The radius was 21 centimeter. And the area was given 462, but we are not going to need that when we find out the length of the arc. Length of the arc is this part right here, right? So length of the arc, what was the formula? Is equal to pi r by 180 into theta. Pi is 22 by 7. R is how much? 21 by 180 into theta is how much? 120 degree as we have found out. Theta is 120. Radius is given as 21 and the others are constant, right? So cancel out whatever you can. 7 and 21 can cancel out. 7 threes are 3 and 180 can cancel out. 3 60s are 60 and 120 can cancel out. 2s are. So when we multiply 22 and 2, we are going to get how much? 44, right? So 44 centimeter. Sorry. So when we find out the length of the arc, how much is the value? 44 centimeter. When length is mentioned, whatever radius, length of arc, or circumference, all of them will have the unit for centimeter or meter, whatever the unit is given. But when it comes to area, you have to have square in all of them. Okay. Okay, copy this. Not a very difficult one. Anything that you don't understand, you can ask. But I think the question is very easy. You all have to draw the figure on the side also. Okay. Make sure that you draw the figure also. All right then. Moving on. Okay. If you haven't finished, just say you haven't finished. Okay. Okay. Before we do the question number 6, you all need to understand something first. We have a clock right here. This is 3, this is 12, this is 6, and this is 9. In total, there is a 360 angle, right? So this is 90, this is 90, this is also 90, and this is also 90. That way 94 is 360, right? And in between 12 and 3, there will be 1, there will be 2. So here, there will be 4, there will be 5, there will be there will be 7, there will be 8, and there will be 10, there will be 11. So if you take only one, if the minute hand goes from, let's say we are counting on the minute hand, if the minute hand goes from 1 to 2. How much will be the angle? Look at this total angle. This total angle is 90 degree, right? The 90 degrees divided equally 1, 2, 3. The 90 degrees divided three ways in equal three parts. So how much will each angle be? One angle, one angle, one angle. How much will each angle be? If the total is 90 degree, one angle will be 30 degree, right? So when it goes from 12 to 1, when the minute hand goes from 12 to 1 angle is 30 degree. When it goes from 1 to 2, this is also 30 degree. When it goes from 2 to 3, it is also 30 degree. So the question says, let's come to the question then. The question says the minute hand of a wall clock is 4.2 centimeter long. Minute hand is 4.2 centimeter long. Find the area swept by it in 20 minutes. In 20 minutes, the minute hand was here in the beginning. This is the position of the minute hand. After 20 minutes, how much will it go? It will go until 4, right? Let me rub off the rest. Right. The rest are not important anymore. Okay. The minute hand is how long? The minute hand is 4.2 centimeter long. 4.2 centimeter. The minute hand is from here to here. So this 4.2 centimeter that will act as what? Radius. The minute hand is moving in a circle, right? So it goes from 12 to 4. In order to cover 20 minutes, it has to go from here till here. How much angle is that? How much it forms a sector right here. It forms a sector. When it goes from 12 to 20 in 20 minutes, 12 to 4 in 20 minutes, it forms a sector right here. The question is asking how much is the sector area? How much is the area swept by it? So the area swept by it will be area of sector, right? The minute hand goes from 12 till 4 in order to make 20 minutes. And in that process, it forms a sector. For that sector, we know the radius. We know the radius is 4.2. What about the sectorial angle? Sectorial angle is this part right here, isn't it? How much is the sectorial angle? When it goes from 12 to 1, it's 30 degree. If it goes from 12 to 4, how much will it be? 30, 30, 30, 30, 34 is 120. So this total angle will be how much? 120 degree. So when the minute hand goes from 12 till 4, it forms a sector having sectorial angle how much? 120 degree. And the radius is how much? 4.2 centimeter. If radius and angle theta are given, it's easy to find out the area of sector, right? So you calculate this by using the information. You mention here radius is how much? 4.2 centimeter. Angle swept. How much angle has gone from 12 to 4? It will be 30 into 4, so it will be 120 degree. This is the angle theta. Now you find out the area swept. Area swept is how much? Pi r squared by 360 into theta. Time to put in the value. You can cancel this 120 and 360. There is a 3 remaining. 7 and 4.2, you can cancel them. 7 and 6 are 42. But since there is a 0.2 in there, you have to put 0.6. You can cancel 3 and 4.2 also. 3 ones are 3, 3 fours are 12. But there is 1.2 because of the decimal point. Now you put down the remaining 22, 0.6, 1.2. Multiply them. 22 and 6, we have got 132. Multiply this with 12, 264, 132, 4851, 1584. And there are 2 decimal points here. So you have to put point. And you put centimeter square. So radius is 4.2 and angle swept is 120 degree. You know how 120 degree is coming, right? And the area will be this formula. Okay, then you have to draw the figure, remember? Draw the figure, copy this. Let's see if you all are able to do that in 3-4 minutes. Now, moving on to the next. So the question number 8 is slightly different from the rest. It says 2 concentric circles have radii 6 centimeter and 4 centimeter. The radius of the concentric circle is 6 and 4. A sector of 60 degrees drawn in each circle. Find the difference between the area of two sectors. We have got two concentric circles, okay? One circle right here, another circle outside. Concentric means they all have the same radius. Sorry, these two have the same center. So two concentric circles have radius 6 centimeter and 4 centimeter. For the bigger one, the radius is how much? 6 centimeter. So let's say this is the sector. From here to here is how much? This is 4 centimeter, and the longer one how much? This is 6 centimeter. And the sectorial angle is also given as sector of 60 degree. It mentioned here the sectorial angle also. So this is 60 degree. Now the question wants difference between area of two sector. You find the area of the first sector right here. This first sector right here, you found out the area. And this bigger sector right here, you find out the area. So the area, there is a difference in area, right? The white part. This area is the difference in area between the two sectors. This sector and this sector. You find out the area of the small one and bigger one, and then you subtract them. Simple as that. So I'm writing the radius here also. Radius is how much? This is 4 centimeter. The bigger one, how much is the radius? This is 6 centimeter. Okay, now time to find out the difference between the areas. So for the first sector, there are two sectors, right? For the smaller sector, how much is the radius? Radius is equal to 4 centimeter. Let's make it R1, okay? So area will be how much? Theta is equal to 60 degree. Area will be how much? Pi r square by 360 into theta. This r will be replaced with r1 because we are taking the smaller sector, and this theta will be replaced with 60. So you replace this. Instead of r, we are going to put r1, and instead of this theta, we are going to put 60 degree. Now we can cancel 60 and 360, so we will have pi r1 square by 6. Pi r1, instead of r1, we can put in the 4 divided by 6. Whatever you can cancel it out. 2 here, 3 here. So we are going to have how much? 8 pi divided by 3 centimeters square. What about the bigger sector? For the bigger sector, we have to make the radius longer, right? We have to take this whole thing, and the radius will be 6. So you mentioned here for the bigger sector, radius is how much? 6 centimeter. Theta is the same. And if you find out the area, make it R1. We will have pi R2 square by 360 into 60. 60 and 360 got cancelled. There is 6 remaining. If you put in the value, then pi into R2 will be how much? 6 into 6. R2 squared. R2 is, sorry, this I put R1 here. Sorry. I have to put 2 here. R2 is 6. So R2 we replace it with 6. Now 6 and 6 can cancel. So the difference we have is how much? 6 pi. So this is the area of the smaller sector. This is the area of the bigger sector. This is for the smaller, and this is for bigger. Now if I want to find out the difference between areas, difference between the areas, you have to subtract them, right? Okay, so you find out here difference between area. From the bigger value, you subtract the smaller value. So we will have 6 pi minus 8 pi divided by 3. There is a 1 as denominator. You do multiplication first, 1 and 3. We will have 3 here, and then you cross multiply. 6 3s are 18, 8 1s are 8. So 18 pi minus 8 pi will be how much? 10 pi by 3. You can put in the value of pi as 3.14. So the final value will be 31.4 divided by 3. If you multiply 3.14 and 10, you will obtain 31.3. Okay. And you do final division. After final division, the value will be 3 1s are 3. 10, 3 4s are 12, 3 6 are 18 centimeters. Okay, you copy this. Anything that you don't understand, say it. And after this question, let's wind up for today. We will take up segment tomorrow. We have done sector today. We will take up segment tomorrow. Okay, copy. Don't forget to draw the figure. All right. And then you share this portion also. This portion right here, you share this because this is the part that we want to find out. Difference between the area of the sector. We will continue on Monday. All right. Okay then, goodbye.